Hey, what's up, guys? Let's move on with what we were studying, and that was projectiles. We learned that projectiles are normal trajectory of a ball, trajectory of an object that is thrown in two-dimensional space. And it is very important to understand that a projectile, it's really not important that a projectile has to go in a pathway like this, right? So the projectile can go in the pathway like this, a projectile can go a pathway like this, and the projectile can go straight down too. Everything that is just thrown is like a projectile. Any object which is thrown in air in two-dimensional space in whichever direction is a projectile. So we can say that if it is thrown in this direction also it is a projectile, if it is thrown in upward direction it is a projectile, downward direction, any direction in two-dimensional space can be termed as a projectile. Now also we had also derived two main formulas in which we had derived the time and the range of the projectile. So the time taken for a projectile to hit the ground once again was 2v sine theta by g, right? And the range which when we put in the formula of r is equal to v cos theta into time, we got it as v square sine of 2 theta by g, where v is the velocity with which it is thrown. V is the velocity with which it is thrown, right? And the theta angle, the angle theta is equal to the angle of throw. I am writing it in a more simple language, angle of throw, right? In which angle it is thrown with respect to the horizontal, right? So this is the main thing that we have here. Now when we look at the projectile, let's say we have a projectile here, we have the ball here like this, and we have projectile like this, right? So we see that in all it has a range r as well as it has a maximum height h. It has to go through a maximum height and then it comes down, and it is very easy to find this maximum time. With the use of symmetry we can say that this maximum height will reach at half the time of the whole displacement or the whole range. That is, like, if we consider that we have a same ball here, right, and it is thrown in this direction, then we can say that it will also cover the same time here and it will move to the same distance, the same height, the maximum height. So we can say that half of the time will be taken to reach that height. And using the formula d is equal to ut plus half at square, we can find out what will be the height. So we then apply the formula of d is equal to ut plus half at square. So h is equal to, I'm directly writing the formula. So if we take the upward direction as positive, we'll get the displacement as positive h. That is ut. U will be v sin theta positive direction, so it will be plus v naught sin theta, so it will be equal to v sin theta. The time taken is half, so it will be 2v sin theta by g upon 2 will be v sin theta by g. Then comes the second part, which is half at square. Now the acceleration to gravity is the downward direction, so we have to take it as minus g. Therefore it will be minus half g, and the time whole square will be v sin theta by g whole square. So v sin theta by g whole square, and we can easily say this is v square sin square theta by g, and this is v square sin square theta by 2g. Therefore this will be equal to, by simple mathematical calculation, v square sin square theta upon 2g. Therefore, the maximum height that it reached is also depends upon the velocity and the theta, and it is equal to v square sin square theta by g by 2g. Right. Now we have find out what will be the maximum height it reaches, what will be the range in which it is to which it will move, and what will be the time taken to it. Now we need to prove the fact that this particle or this object is moving through a parabola in this trajectory, which can also be easily find out in a mathematical sense. So let us suppose that we have this ball here. And what is happening is this ball is moving in a trajectory like this, the parabolic trajectory which we have assumed. Let's say it is moving in any trajectory, it is moving in a projectile trajectory. Now let us assume that it has reached at some point here, and what we do is we make x and y axis here. So let this be the y axis and this be the x axis. So what actually has happened here is that it has moved by a distance of x and upward distance of y. So that means that here this is y and this is x. Right. And let's say this is at time t equal to t. Let it be time t equal to t. Right. So now we know that this thing here has a velocity of v sine theta in this direction, v sine theta, and a velocity of v cos theta in this direction. Acceleration is g downwards. Right. So we can easily find out y at time equal to t and x at time equal to t. So what we do is first we write the formula for the horizontal direction. So for this direction, horizontal direction, I can easily write that x is equal to v cos theta into the time taken t. Right. So this will be equation number 1 for us. Now applying t is equal to ut plus half at square in the vertical direction, we will get y, because it is in the positive direction, I have taken upward direction as positive, y is equal to v sine theta into t minus, because the g is in the downward direction and downward direction is taken as negative, therefore minus half g into t square. Now from the first equation we can find that t will be equal to x upon v cos of theta. Therefore when we put the value here, we get v sine of theta, t is x upon v cos theta minus half g x upon v cos theta upon x upon v cos theta whole square. And this in turn will give us v and v will get cancelled here. Sin theta upon cos theta will become tan theta, and therefore at the end we will get this is equal to tan of theta into x. Tan of theta into x minus, write it here, minus half g by v square cos square theta into x square. Right. So this is the equation of motion that we have. So in a very good form we can write y is equal to x tan theta minus half g by v square cos square theta into x square. Now you can see that there is a term of x here. We have a term of x here and a term of x square here. Right. So we have two terms x and x square, which in turn give us a parabola. Therefore it is easily proven that if there is no air resistance or any friction happening, then this must be a parabola. Right, and the equation of the projectile or equation of the parabola is given by y is equal to x tan theta minus half g upon v square cos square theta into x square, where I do not need to explain you that what is v and theta. Right, now we can also find this in the form of range. Right, because we want to prove that the root of this equation, that y equal to 0, we need to find that if y equal to 0, what will be the value of x. So let us find out at y equal to 0 what will happen. So at y equal to 0, we have x tan theta minus half g upon v square cos square theta into x square equal to g. From here we'll get x common, tan of theta minus half g over v square into cos square theta into x equal to 0. Therefore from there we have two values of x equal to 0 or x equal to 2v square cos square theta into tan of theta upon g, and we know that tan theta is equal to sin theta upon cos theta. So tan of theta will be sin theta over cos theta, and cos theta will get cancelled. Sin theta into cos theta into 2 will give me sin of 2 theta, and this will be equal to v square sin of 2 theta by g. Right, so I have two values here. First is x equal to 0 and x equal to v square sin 2 theta upon g. And when I look into this formula, look into the picture of the projectile, I can see that at x equal to 0, this is 0 comma 0, this is r comma 0. Right, so at 0 comma 0 also displacement is 0, and at some r comma 0 also displacement is 0. So we can easily say that this is 0 comma 0, so this is the origin, and this is the point r comma 0. Therefore from here also we can get that r is equal to v square sin 2 theta by g.